What I have here is a global positioning satellite transceiver. It determines your location and helps you find out where you are in the world. But without these, it's useless. Hi everybody, welcome to Rocky Mountain Survival and Homesteading. My name is Sean, and today we're going to go over land navigation and how to read a map and compass. So what I showed you earlier was my GPS. Now, GPSs are great because they're accurate, they're quick, they're easy to understand, they're easy to learn and use, but they're only as good as the batteries. Now, the batteries can die, and especially if it's cold outside or it's really cold below freezing, your batteries are going to last a lot less, or a lot shorter lifespan. They're going to have a lot shorter lifespan, and you're only going to be SOL if the batteries die, and this is your only way of finding out where you were, and your batteries are dead. You're screwed. And that's just one of the reasons why GPSs are bad to rely on, to put your life on, because any number of things can go wrong. The equipment could malfunction, the satellites could not function properly, you might not even be able to get a good satellite signal where you're at. So there's lots of reasons why you wouldn't want this to be your only way of navigating. So it's always good to know the analog version of land navigation versus just the digital version of land navigation, because digital equipment fails. It can, Murphy's Law states anything that can go wrong will go wrong. This has batteries will die. That's all there is to it. And satellites may go down, may not work, may not be accurate, may not get good view or good signal to where you're at, and you're not going to have, you'll be lost. Or if you are lost, you won't be able to get found. Or it'd be harder to get found anyway, I should say. So what is a map? A map is a two-dimensional representation of a three-dimensional surface. It has things like the title of the map, the scale of the map, the legend that's on there, the contour interval, the declination adjustment, all these kind of things that are very important to map reading and what you need to know. So here we have a map of the Weminuche Wilderness. The title of the map is right here. This is a National Geographic map, and it gives a little bit of a description of the history of the area. Next we have this scale, and in this scale we find the scale is 1 in 63,360 feet, the contour interval, as well as the legend, and the declination adjustment on this particular map is located somewhere else. I'm going to show you that here in just a second. What is a better map to use? So the smaller this number right here, the more accurate you're going to be able to get, the more detailed your map is going to be. The larger this map, the larger area the map is going to cover, but the less detail you're going to get. So for out in the wilderness, and you're actually out in the backcountry doing these things, you want to get the smallest number possible here, while still being able to have a wide range of map, a wide area covered. So I suggest a 1 in 24. You're going to get pretty good detail and accuracy, and you're going to cover a pretty good area. Now you're going to need multiple maps maybe for depending on where you're at, but that's part of what you use a larger map for, is to identify where it is that you're going and what maps you will need for the future. Now what we have here is a declination, and on this map it's a bit different. It's actually located on the actual surface of the map, which can make it kind of hard to find, but it's still there, and this is important. And I'm going to show you on a different map because it's easier to see on that one. Now this is a different map. This is actually a 1 in 24,000 map, much more detailed than the last map. Now this is what we're looking for right here. This is the declination. This whole area right in here. This shows the difference between true north versus what the magnetic north is. So this is going to show the difference between what your compass shows versus what the map shows. And it's important to recognize this difference, and it tells you the degrees. So to convert true north, which is these lines here on the map, to magnetic north, which is what your compass is going to show, you'd have to add or subtract depending on what your longitude is. And we'll go over this in more detail. So when you look at a topographic map, you have to identify what all these little squiggles mean. Squiggles are the contour of the landscape. It kind of dictates what the landscape looks like rather than just giving you a flat piece of land and a bunch of green. So by adding these lines in there, you can see the different changes in elevation throughout the map. So the one we're going to look at right here is this 3,000. So from 3,000, which is the index line, you'll see a much bolder line throughout the map. And you look at them all and you can see different ones. So this one here is 3,000, and the next one moving up in elevation is this one right here, which we follow this line all the way over here, and we'll see that it's actually 3,250 is the elevation for this one. Now we count the lines in between them. Starting with the first bold line, we go 1, 2, 3, 4, and the fifth one is 3,250. So if we take the difference between the two, which is going to be 250 feet, we get that by doing 3,250, and we subtract 3,000, and that gives us 250, and we had 5 lines in between them. So 250 divided by 5 equals 50. So now we know that between any one of these two lines is 50 feet in elevation change, whether that's up or down. Now, the next thing we need to know is the different terrain features of the map. And there's some primary ones that we need to know, like hill, valley, ridge, depression, saddle, draw, spur, and a cliff. So there's many different types of land navigation or map reading map formats. There's latitude and longitude, there's UTM, there's MGRS, all kinds of different ones. For the purposes of this demonstration, we're going to go over UTM, which is the Universal Transverse Mercator. In my opinion, it's the easiest one to learn because it's based off of tens, and especially the fact that I'm used to the military grid reference system, or MGRS, it transfers over very easily. They're almost identical. There's very few differences between the two systems. So we're going to go over UTM and how they work. And when you look at this map, you can see this is a National Geographic map, and we have blue numbers and we have black numbers. The blue numbers are the ones we're going to worry about. We're not going to worry about the black numbers. That's for latitude and longitude. The blue numbers is what's important to us. So the numbers on the top determine your easting, or where you are in relation to west to east or east to west. And that's going to run all the way across this side. Now the numbers on the right or the left side determine where you are in relation to the equator, or north and south. And those run across here or on the other side of the map in the same position. So you always when you're reading UTM, you read right and up, which means you'll read these numbers here first, followed by these numbers here second. So the first thing I'm going to do is I'm going to go to my map. I'm going to find my scale right here. I'm going to take a piece of scrap paper. I'm going to place it right up to the scale. I'm going to mark off 1 kilometer. So you have 0, 1, and 2. So this whole bar is 2 kilometers, and right here is the middle point of 1. So I'm going to mark that. I'm going to mark the center point. So now I have these marks that run 1 kilometer, and this is half a kilometer. Now I'm going to divide this up into smaller sections, where I'm going to have these. I'm going to have 0 from here all the way to 10 over here. And this one here will be 5. And I'll have 1, 2, 3, 4, and then 6, 7, 8, 9 on this side. And you'll see why I do that in just a second. Okay, so what I've done here is I've made a bar that has 1 tick at every 100 meters on here. And the way I did that was by looking at this here. It says 1 centimeter equals half a kilometer. Let's mark that out. Every 2 millimeters equals 100 actual meters on the map. There's a little bit of math, not too difficult. There's other ways you can do this just by folding the paper several times to try and split the difference continuously to get farther and farther. But each one of these ticks is a 1. So this first one is 1, 2, 3, 4, 5 in the center, 6, 7, 8, 9, 10 on the right. Now this is how I'm going to actually be able to get my location on the map, and I'll show you how that works right now. Okay, so the first thing I want to do is I want to identify what grid that this is in. Now I'll run to this corner here, and it'll be in this area right here. This area right here, and it'll be in this grid square. So I find out what two numbers line up with this point here in the very center, which, since I'm reading right and up, I'm going to read the numbers running right, which I've already written down here because you can't see that. And that is 464 on this line here. So the grid lines come in here. This is 464, this is 465, 467 over here, so on and so forth. So I'm going to write down the one in that corner, which is 465. And then for this side over here, I'm going to follow this line over here and see what that lines up to, and that's 4346. And now remember, the numbers on the right side of the map are your northing, and the numbers on the top of the map that run left to right is your easting. So I've decided that I want to find the coordinates of this peak right here, which is named after its own elevation. Basically, it's an unnamed peak. And this one is 10,050 feet above sea level. So I'm going to find the location of that. Now the easiest way to do this is to take a straight edge and put a tick on the edge of the box, the grid square that it's located in. So I'm going to line the upper edge of my paper here up to a grid line and make it straight up against that. And then I'm going to run it so that it crosses over the center of my point right there. And I'm going to use this straight edge to put a tick right on the grid line. I'm going to do the exact same thing on the other axis. By lining it up with this line right here on this side, and then sliding the paper over my point. And I'm going to mark it around the edge of that line. Now I can take my scale and I can place it right on this. And I'll mark the 0, put my 0 right on the grid line, and I'll count. So I'm at 5 right here, so that's going to be 6, and that's 7 right here. So this is 5, 6, 7. So it's right actually in the middle of 6 and 7. So I'm going to use that as a 6.5 because it's in the middle. I'm going to write that down. 6.5. And I'm going to do the exact same thing for this side. I'll put the 0 back down in this corner over here, come up, and I'll count 1, 2. It's right on that 2. So I'm going to write that down separately. So that's a 2. Or since I used 2 digits in the second one, I'm going to use 2 digits in this one too, and that's going to be 2.0. And then okay, so now what I'm going to do is, now that I have the smaller numbers, I'm going to add those to the bigger numbers. My first number was 465, and then I found that same axis over here to be 6.5. So I'm going to add 6.5 to this one. So the first portion of my coordinate is 465, 6.5. Now I'm going to add the second number that I found on this axis here and add that to the second number for the larger grid, which was 2.0. And I'll add just 2, 0 on the grid. So that number is now 434,620. Now what I've just said is my actual grid coordinates to 10 meter accuracy. So this will get me within 10 meters of that peak, this exact peak right here. So now I'm going to mark a second peak in this area that I want to travel to. And I've chosen this one right here. So I'm going to do the exact same thing I did before. I'm going to get the bigger grid square. I know that it's in this grid square right here. And to find that out, I need to go to the bottom right corner of that grid to find out what that point is. So now that I know that this grid right here, this 1,000 meter grid square, the location for this point right here is 463,4345, which will get you right to this point and will put you in this whole grid square right here. So now I got to break it down even smaller, and for that I'm going to use my scale again and draw my lines. So I'm going to draw my straight line from here. I'm going to line this up with this grid square right here, and I'm going to drag it over until it crosses the center of my point, or that peak. And I'm going to draw a line in the bottom of this grid square. I'm going to do the same for the top one. I'm going to line my edge of my paper up along these grid squares right here. On the blue ones, I'm going to drag it down until it crosses the center of that point. I'm going to draw my line right here. I'm going to call it good. And then I'll bring in the scale. And I'll read my bottom numbers first, which is reading right and then up. I'll line it up on here. See that it's just in the center between 5 and 6. So I'm going to call that a 0.5. And I'm going to call that 6.5 for the whole thing. For this axis of the grid. I'm going to do the same thing. On this axis, I'm going to line this 0 up with the bottom right hand side of this. And count these all the way up, and it's right on 9. We're going to call that 9. So I'm going to write down 9.0. Now I'm just going to add those two digits to the original numbers I took, which, if you remember, was 463. Now I'm going to add 65 to it. And the bottom number, my second number, was 4345. I'm going to add the 9.0 to that as 90. So now I have the grid coordinates for this one here and this one here. The location of this one was 46565, 434,620, and the location for this one was 46365 and 434590. So it's just the basic land navigation, and a lot of times it gets really hard for people to handle because there's just so much information thrown out at once. But really, it's not that hard. You just have to break it down into smaller pieces, practice those, and then move on from there, and then just keep practicing each consecutive step, and then adding all together, and then eventually it'll make sense to you. So what I suggest is practice, finding elevation for. Just pick a bunch of points on a map, find the elevations of them, and once you get good at that, you're good at reading contour intervals. And then move into plotting points. Just pick points on the maps. You don't have to just draw around. You just pick different points. You already have the elevation to them, typically, or you just find the elevation. But then you can plot those points, figure out where they are, and then you can correct to them too. So if you have a map that has an area that you go to frequently anyway, like maybe a park or anything like that, and you do carry a GPS, mark a point on that map that you can identify, like where there's like a park entrance or the corner of a lake or a bridge or something like that. Plot the point, and then go to that area with your GPS and see how close you are. And the more times you do that, you'll start to gain confidence with it, and then you can start, not relying so much on your GPS and more on your actual skills. And this will help you to just gain more confidence in yourself and your map reading ability. That's the only way you can really check yourself, is by doing that. So the next thing I could suggest is just make sure you practice. Practice. This is definitely a perishable skill. If you do not use it on a regular basis, you will lose your, at least you lose your confidence. You lose your confidence in your ability to read a map. Now, today we just went over the map reading portion and putting points on the map. It's really hard to teach someone how to read a compass without being there to guide them, and the last thing I want to do is make things harder for you guys, and then you go over there and you get lost. So I don't want to do that. So I suggest learning how to read a compass from somebody who knows how to read a compass. Either that's through a class or somebody else you know. It's hard to show a video. I could show you certain things, but you wouldn't get the whole picture, and I think it might just make it more confusing. So I'm going to stay away from that for right now. So that's going to be it, everyone. Thanks for watching. Make sure to like, comment, and subscribe. Tell me what you think, and stay tuned for more videos on outdoor survival, backpacking, and homesteading. Thanks, everyone. Have a good one.